Welcome back again. That was a long lecture on how to do replatform. Hope you remember where we started. We were discussing different migration strategies, and in that discussion, I have also shown you how you do rehost, how you do replatform, and now we are focusing on refactor. This is a very specific situation when you would be using refactor. When you want to break down a monolith application into microservice, probably to achieve high availability, enhanced level of automation, that time you will probably go for refactor. Idea of refactor is whatever application we had, maybe it is not very well designed. Either they had a lot of issues in that, or maintaining it is very complicated, or it may not have the scalability you are looking for. It may not be compatible with other things you want to do. So let's tear it apart and probably create a new application on top of it. It won't change any experience for the user. User would still see the same, but internal architecture of it would be modified. That's what we mean by refactor. That's why it is also referred as redesign or re-architect. Because technically you are redesigning the whole application. Now, scope of this could be smaller or bigger in the sense that you would decide to make a change into a redesign only a specific section of your application or the whole. It purely depends, but you are basically trying to come out of the challenges you were facing with your monolith or your on-prem infrastructure. Let's focus on the good, bad, and ugly of it, and then we'll talk a little bit more on that. So the good part about refactor is once you have done refactoring, you get higher return on investment because now you have embedded all the features of cloud like scalability. You have reduced the consumption of resources and therefore the cost would also be coming up because you have started using cloud infrastructure. All the best things of cloud like pay-as-you-go model, serverless architecture, maintenance-free options, managed services. This is what you would be using when you are redesigning. Like when you're remodeling your house, you won't be going back to the old design. You would be designing it in new fashion, and probably you would use the new options available, like you would use more energy efficient geysers, maybe you will use more energy efficient wiring, maybe you would use more energy efficient wall covering or any number of things, or maybe electric switches or light fixtures. It depends. So this will make your application most future proof, and that will be helping you in long run. But there are some challenges also with this approach, as it would be happening with every approach. The process requires thorough planning, execution, and testing to prevent error from causing cloud security, performance, and cost problems. Very complicated thing. Why? Because you are basically redesigning the whole infrastructure, whole application, and that's why you need to plan it properly. Plan is one part, executing it properly is also required so that you do not have any issues and your customer do not complain about any problems in that. Also, application can partially become logged into certain public cloud provider due to reliance upon cloud native feature. Again, this is may not be that deterrence, but let's say you used a service like SQS. Now that SQS service may be proprietary to Amazon or AWS, or maybe you have used other service provider, other cloud providers specific services. So you may end up into a public provider, you may end up into you may end up logged into a public cloud provider, but that is still okay. It is much better than having your on-prem complicated environment. Then what could be the ugly part associated with that? Often it is considered the most complex migration process, as executing it takes the most time, effort, and money. I don't expect a complicated application, let's say a mainframe application or AS400 application, to be just refactored in a day or two. It may take months, even years, and it would require a lot of time, lot of money in terms of resources and then testing, validation, planning. So that is going to be costing a lot of money and time. Be aware about that. Extensive planning, training, cloud expertise is required for refactoring. Maybe your developer do not know how to build the cloud-based application, so you have to train them. Once they get trained, that doesn't mean that the next day they would be able to build a complete application on enterprise scale. They may need to do some experimentation too. So that's where this can become a really, really challenging thing. Now, specific services, obviously you could use any services of your choice when you are refactoring. You may say I am going to use serverless Lambda function, I am going to use S3, I would be using containers, I would be using SQSQ, I would be using Kafka. It purely depends on you, but there are some tools to facilitate your migration using refactoring, and that is called AWS Migration Hub Refactor Spaces. It is very specific. It will be utilized only when you are refactoring that application, relatively a new offering. So let's talk a little bit on AWS Migration Hub Refactor Spaces. I won't be able to show you a complete demo here because that would require a lot of programming, and I would say what we are going to discuss here is the infrastructure part of it. On the programming part, like how to break it into monolith application, how to create decoupled architecture, those all will be mostly will be your developer approach or your design approach. So we are focusing on here what is AWS Migration Hub Refactor Spaces. So it is an application transformation feature. What does it solve actually? It sets up the infrastructure for refactoring, rewriting and re-architecting apps. So when you creating this architecture, when you're rewriting things, I don't expect it to happen overnight. As I said, so you would need an infrastructure where you can get data to your monolith also, and gradually you could shift it to your microservice based architecture. Sometimes it is called Strangler Fig pattern also. Check for that. Interesting phenomenon. Strangler Fig pattern. So check for that. Let me write it down so it would be easy for you and you won't be bothered by my pronunciation which I am doing. So that phenomenon is called Strangler Fig pattern. This is coined by Martin Fowler, a well-known name in system design. So check, this is not Strangler Fig pattern. So check that. So what does it solve? It helps you to build an infrastructure where your refactoring and rewriting can happen properly. It operates app at scale while you are making the changes, so it will not block traffic to actual app. It will let it go and it will be partially shifting traffic to the services which you have refactored. What does it orchestrate? So what this tool is doing, Migration Hub Refactor Spaces, it is basically creating an infrastructure layer for you to easily route traffic, and that is done through your AWS Transit Gateway, and it will be creating some VPCs to bridge networking across account, and we will expect that you would be having multiple account. In one account your monolith will be working, in another account you would be hosting your application in microservice format which may spread across multiple accounts. So that's what be the mechanism of VPC connections, and that will be facilitated by Transit Gateway. It will be deployed automatically for you. Then it will also be setting up your API gateway and VPC link for external API so that they can transparently access your new services and then can incrementally route traffic from old to new. So that will be possible using it. Now, there is a good documentation available and there is a workshop available. So I'm putting a link here. Please go and check this workshop studio where they will help you in how you iterative app modernization, how you do iterative app modernization workshop. So check that. So you will be first checking exploring monolith, then you will be going into Migration Hub Refactor Spaces, you would be deploying something, then you will leverage this architecture, use DynamoDB and then Lambda. So pretty interesting lab, but it would require a little bit more planning. And if you know Amazon, they love Unicorn and they have created a front end of a website using Unicorn, the Unicorn shop, and its architecture is completely into a standard way as of now, and you would be moving forward and making it readily available in a microservice architecture. So check this architecture where they talk about what is currently it is architecture like this, and then you would be evolving to a more robust architecture, and that is where your refactor space will be coming into picture. So this will be a good workshop to check into. Go ahead and check that, and if you are interested in that particular way, go ahead and try to implement the solution provided in the workshop. Let me quickly give you overview, so if you want to do workshop or not, you at least know what is actually refactor space is giving you. So consider this is account, and in this account you have your monolith application. Let's consider it is running into a private subnet. You would still have a way for sending traffic to this private subnet. Let's say you just did a lift and shift of that application. Now what I want to refactor it. So I would go ahead first in my Migration Hub Refactor Spaces, and I would be creating an environment. When you create an environment in a separate account, we would be setting up these components for you. Means you just go through Wizard and say I want to deploy these things. So there would be API gateway. who would have connection to a network load balancer. That network load balancer would be connecting to a transit gateway for communication, and now your entry point will be this API gateway. Once this is architecture is ready, once your migration hub refactor spaces is deployed, what you would be doing, you would be saying, okay, let me now add the account where my monolith is running. So we would be creating this kind of a networking architecture where your traffic for the application is completely being forwarded to monolith application as of now. Once this is done, once you have your application ready, once you have an entry point secured, what you would do now, you would go ahead and say, okay, let me go ahead and configure or create my application. This is where I would be creating the microservice based architecture. Like in this case, we were running monolith application on instances. We have deployed now a Fargate based application which is running into private subnet, and I have an application load balancer. Obviously, I would be needing now connectivity. So we create services within VPC and we add route so that my physical connectivity is sorted now. And after this is done, you would configure here into your API gateway different paths so that your request can be rerouted to the destination, which will now become your Fargate based services. So you will do path based routing using API gateway, and now your request will be forwarded, and eventually when you are able to create a equivalent for this application into your VPC, then you would probably be breaking this connection and will be decommissioning this monolith which you have created. So your user do not see a difference, they still see the same output, but behind the scene the traffic is being routed to the newly deployed or new architected application. So that is the main idea of migration hub refactor spaces. Now, can you not do all these things manually also? Yes, you can. You can set up a API gateway, network load balancer, transit gateway, and configure routing. But having it done through migrations hub refactor spaces ensure that you focus more on the application re-architecting rather than building the new infrastructure altogether for it. So I hope that you got a little idea on what is migration hub refactor spaces, and we will be talking about the remaining migration strategies into the next section. So please join me into next section and we'll discuss remaining hours of migration. Thank you.